screen. And I need to put y'all on the TV monitor. And we are good to go. Okay. Now, first thing I want to cover is we're going to go through this again because I do this several times. So all those people that I'm talking about won't come up to me and email me and go, you know who I'm talking about. You know, just act like they don't know what day it is. Are y'all still there?
Yes.
Okay.
Yep.
Because everybody went, okay, I guess everybody, okay. I'm noticing things because I usually have to, okay, I'll shut up. Anyway, last day of class is Wednesday, July 22nd. At midnight, homework that is due will terminate on that day. Okay. On 7/23, the last test and the final exam will engage, and they will both cut off on 7/27 midnight. The last test will consist of Chapter 5, homework that I'm going to put up on Chapter 2, y'all help me out, and homework that I'm going to go over today, which is Chapter 6, okay, which is going to be about 5 questions. That's going to be about 5 questions, and that's going to be about 5 questions. And you should be able to answer them because I'm going to make the homework and I'm going to base it off of the questions that I showed y'all. Okay. And this, Chapter 5, is going to cover 5.4, 5.5, Hubert's homework, and that's going to take care of 5. All right. The final exam, you get 2 tries because lightning's going to hit your house on the first try or something's going to happen. And you have 2 hours. It is not a 2-hour test. I make it basically about 50 to 60 minutes when I make out the test. It usually has, well, a calculus test, I doubt I'm going to have more than 25 questions. It will cover your cumulative, it will cover all your unit tests. You can go to your grade book and pull up your test and your homework and hit the review link. You should be able to review your test. And it takes the highest of the 2 tries. Okay, 2 hours, you got a week to take it, 25 questions, 2 hours, 2 tries, unit test, review. And when you are finished with those 2 items, when you are finished with the last test and the final exam and you're satisfied with your grade, in other words, you don't want to take it again, then all you have to do is hit grade book and what? Final grade. And whatever that grade is, that is the grade you got. If you want to make it better, then you go back and take the final exam again and the last test and try to get a better grade. Okay? That's pretty much it. Okay. Here's the homework question that I gave y'all. F of x is equal to x to the 4/3 plus 4x to the 1/3. Now, the first thing we want to do is find f prime of x. And that's going to be 4/3 x to the 4/3 minus 3/3. And I'm putting an extra step in there just to help you out because it's been a while since we did derivatives.
Hart says she is
1/3.
attempting to restart her computer because she can't hear you.
Who is Miss Hart? Okay, thank you. 1/3 times 4, sorry, x to the 1/3 minus 3/3. Now I put that extra step in there, like I said, to help you out if you've kind of forgotten, you know, with fractions. And that's going to give us f prime of x is equal to 4/3 x, 4 minus 3 is 1/3, plus 4/3 x minus 2/3. That should be your first derivative. Now, you can factor out, and the reason we want to factor out is because we're going to set equal to 0, your lowest denominator, and of course your common term. So I'm going to factor out f prime of x is equal to 4/3 x to the negative 2/3 parentheses, and that's going to leave me with x plus 1. And now you can set that equal to 0. Now, you don't need to really hurt yourself because, you know, there's 2 multiples there. So you just set each one of them pretty much equal to 0. And you can bring that 2/3 down. So that would be 4 over 3x to the 2/3 times x plus 1. And that would be what I would set equal. So the 3x to the 2/3 is equal to 0. And x plus 1 is equal to 0. And that's going to give me 0 and negative 1. So there's my critical points. Did she get back in? Let me see if I can pull her up. I don't see her. Let me pull her up. Hart, H-A-R-T. See if she'll come back up now. Oh, me, I'm not going to say anything. Shut up, Hubert. Okay, so draw a number line. Draw your number line. And this is negative infinity. This is positive infinity.
Quick question.
And we've got a 0 and negative 1.
Professor, we have a question.
Oh, yes.
Would 0 not be undefined?
Yeah, I'm getting there. Hold on.
Sorry.
Hold on. Yeah, I'm getting there. All right. So you've got, we'll go ahead and put it right here, undefined, right there. So there'll be like a little blip on the graph, and or be a it might be a cusp like this, you know, with an undefined point there. It might be a like that with a blank or an open circle there or something like that. Okay. So we plug in -2. Yeah. I made my it's too crunched up, but anyway, and a 1 And I'm going to highlight my two, I'm going to highlight my critical points so I know what I'm looking at. There's my critical points. So now I plug in a 1, a -2. I'm going to get negatives. Let me do red so it won't blend in. I got negatives right here. I plug in a -0.5 and I get, we'll use blue, positives. And then I plug in a 1. When I plug in 1, I get all positives. So we've got an increase, we've got a decreasing function. So it could be something like this, and then increasing, something like that. Now remember, we don't have an inflection point, so we're just kind of sketching a part of a sketch. In other words, we don't have any idea, we're just sketching. So now we got to go and do the second derivative. So I'm going to rewrite my prime over here. So that's going to be f prime of x is equal to, excuse me, set Rona, 4 over 3x to the 2/3 times x plus 1. Of course, you're going to use the product rule. I meant the quotient rule because of that. You could put the x plus 1 on top. That might make life easier. Yeah, let's do that. Let's make it 4 times x plus 1 over 3x to the 2/3. And that way this is on the bottom with the square, and that'll help out a little bit, make it a little bit easier. So when you put it in the quotient rule, you're going to get 3. So f double prime of x is equal to denominator times numerator prime. I'm going to put a 4 there, because even if you change this to 4x plus 4, the derivative is going to be 4. Minus the numerator, 4x plus 1, times the derivative of this guy. So I'm going to put parentheses in blue, or just a dot there, parentheses. Okay, something's up with my, what the heck just happened? Sorry about that. I don't know what just happened.
You said blue and Siri took you to blue.
No, this thing went crazy. I don't know what it was doing. Okay, I'm sorry. Okay, that's going to be 2/3 times 3 x to the 2/3 minus 3/3. And I'm going to put that extra step in there. All this over 3x to the 2/3 raised to the second power. Okay, now we're done with the calculus. Now take your dang old algebra and crunch it down. And that's going to give us, that negative, that's going to be a -1/3 right here. That's going to come down. So you're going to have 12x to the 2/3. I'm going to put that negative in red because I don't like to do that until the last very minute. And that's going to be 8 times x plus 1, because that 3 will cancel. Let's go ahead and cancel that with the red pen. That 3 is going to cancel. And then what's 2 times 4? 8. 8 times x plus 1 over x to the negative, or x to the 1/3, over, and let's put a 1 under here because we're going to have another complex rational equation. That's going to be 9x to the 4/3.
Yes.
9x to the 4/3 over 1. Now, the reason I'm adding those ones is because we're going to multiply by a common denominator, which is going to be x to the 1/3 up top over x to the 1/3 on the bottom. All right, go ahead and work that out because it's just algebra. You're going to multiply that x to 1/3 times this. X to 1/3 times this, they're going to cancel. X to the 1/3 times this. So go ahead. Give you a few seconds to do that. Or you could just throw your pencil down because it's got so many fractions in it.
I was going to start playing the Jeopardy theme song.
Okay. So I'm just going to write it out for you. 12x to the 2/3 times x to the 1/3 minus brackets 8x plus 1 over x to the 1/3 times x to the 1/3. That's the whole purpose for doing this, is to get rid of that. 9x to the 4/3 times x to the 1/3. And I'll split this. And that's going to give you, well, 1/3 plus 2. 1 plus 2 is 3/3. Oh, heck, that's going to give us 12x. Isn't that nice? Minus, I'll take my red pen. And that's a minus right there, that negative, and I'm going to put this bracket. I'm going to tell y'all a little secret. I don't tell too many people this. When I was in college algebra and college trig, and I was getting ready for calculus, do you know one thing that gave me fits? Do you know the one algebraic procedure that gave me fits? Anybody want to take a guess?
I'm going to go with proofs.
No, the one procedure that gave me fits, and you're going to laugh because you're going to say, oh, that's easy, was distributing a negative. When I was in college algebra, this is, I'm not proud of it. I tell it to y'all, tell it to some people, because there's some quirks that students, it takes a while for them to get over. And the negative, I bet I turned over at least 2 or 3 desks because I would get 2 or 3 problems wrong on an algebra test because of distributing the negative. So if you wonder why I do that red pen and I do that negative, it will get you. So you better be careful. Okay, that negative will get you.
I wish that was my issue.
Say again?
I wish that was my issue.
That's one of the biggest problems I had in math. Now you got to think about it. In algebra, in algebra 2 or algebra 3 or college algebra and this, how much would that negative make a difference? It's in every single problem. Think about it. When you distribute a negative. Oh man, it gave me fits. And 12x minus 8x is 4x. minus 8 over 9x to the 5/3. And you can do one more step, 4x minus 2 over 9x to the 5/3. And this is going to give you a similar, but remember, we're looking for concave up and concave down now. So I'm going to go up to the top of this page. And we're going to do concave up, concave down. 4 times x minus 2 is equal to 0, or 9x to the 5/3 is equal to 0. And of course, you get x is equal to 0, which is undefined, so it's going to have an open circle on the line, and we've not worried too much about that. What we're worried about is just doing concave up and concave down. And this divided by 4, x is equal to 2. Okay? So we've got two critical values. So I'm going to draw handy dandy number line. And that's going to be 0. And that's going to be 2. And I'm going to highlight those as my critical values, because I forget, and that helps me out to know that those are my critical values. And I'm going to plug in a -1, 1, and a 3. So when I plug in -1, I'm going to get a positive. I'm going to put positives in blue. When I plug in a +1, I'm going to get negatives. When I plug in a 3, I'm going to get positives. So this is concave what? Up. This is concave up. And this is concave down. So if I was to draw this on a sketch, I would draw it like this. We know that 0 and 2. So I'm going to just draw I know that 0 and 2, 1, 2, we can go ahead and plot those. 0, if you plug 0 into the original function, you get 0 plus 0, that's 0. And then if you plug 2 into the original function, good gracious, I have no idea what you get. But we know those are inflection points. So that means that something is transitioning right there. And something is transitioning right there. So if I was to say, that's probably what it would look like. So we take our handy dandy graphing calculator, and we do y is equal to, turn it on first, y is equal to x to the 4/3, x to the 4/3 plus 4x to the parentheses 1/3. And there would be an open circle at 0. I'll put an open circle right there. And graph. And I'm not even going to try to, but you'll see a saddle. Maybe I can move out a little bit more, zoom out. I'm going to move it down here a little bit. Let me hit zoom fit. Okay, well, it's right in here, somewhere in here. So you're gonna have to go in there and look. Let's zoom in, and I'm gonna move over and down. There's the little twerk right there, whatever it is. You got concave up right here, concave up, and then keeps going. So I don't know why I didn't get that, but it may be doing something funky right in here. The whole point is that you be able to take the first and second derivative, okay? All right. Now let's move on. And that's somebody, Miss Hart, how many problems was that we did with the first and the second derivative? 4?
Today or yesterday?
No, yesterday and today.
Yeah, about I don't know, 4 sounds right.
Okay.
It was a good 3 or 4.
Okay. All right. This is the good stuff. This to me is easy. Okay. Now, when I did this in calculus, I remember doing this because I thought it was easy, but I don't know. Maybe I'm crazy. Y is equal to X. This is finding the area between two curves. Y is equal to X squared. Now, the first thing you want to do is graph the two functions. So 1, graph. Now, that means graph with your graphing calculator and then sketching it on your notepad or notebook or whatever, because you want to see what the two functions are doing. So go ahead and graph those two. I'll be graphing them, and I'm going to do it in the first quadrant because most of these are going to be in the first quadrant. And your y is equal to x is a 45-degree angle. And your y is equal to x squared. I'll do that in another color. Let's do that in pink. Y equal to x squared is this function. Okay, parabola. The second thing after you graph is find intersection points. Did anybody remember how to do that in algebra?
Vaguely.
Set them equal to what?
To each other.
Good job. You are a shining example. Set them equal to each other. I'm sorry, you can't see because the damn calculator. There we go. Now, I don't care if you're in Calc 1, I don't care if you're in Calc 3. These are the things you're going to do. All right? Once you find that, that's your parameters. That's your A and B. Or B and A, whichever. However you B and A, it should be B and A. Okay? In other words, when you set up your antiderivative, your intersection points are going to be your parameters. So 0, I think this comes out to be 1. Let's go ahead and check. X is equal to x squared. 0 is equal to x squared minus 1. Oh, x, sorry. 0 is equal to x times x minus 1. X 0 is equal to x. 0 is equal to x minus 1. 0 is equal to x, and 0 or x is equal to positive 1. So there's your two intersection points. So you're going to set your integral up from 0 to 1. Area between two curves is equal to 0 to 1. Okay, so this is 3. Take those 2 points, put them right there. And now is the important part. Your upper minus your lower. Now that's not in any book. That's straight from, that's a Hubertism. Your upper function minus your lower function. Now in this case, which one is my upper function? Which one is the upper function?
I guess the black one.
Well, it's not black, it's blue, but yeah. The straight line is the upper, because how do you find that out? Well, pick a point right here within the parameters. Let's pick 0.5. What's 0.5 raised to the second power? 0.25. What's 0.5 right here? 0.5. Which one's greater, 0.5 or 0.25? 0.5. So whatever gives you the higher y is your upper function. Does everybody understand that?
Yes.
Yep.
Good job. So that's 0.25, and this is 0.5. So the blue function, or the straight line, is your upper function. So now I'm going to set up my antiderivative, or my definite integral. 0 to 1 of x minus x squared dx. And now what are you ready to do? You're ready to take the antiderivative and plug and chug. So go ahead and do it. Do the antiderivative and then plug and chug. I'll do that on the next page. I used to have fun doing these. I used to love doing these.
This is why you're a math professor.
Yeah, I guess. I used to. There's a lot of math classes I didn't like. Advanced Calculus 1, Advanced Calculus 2, Abstract Algebra. No, I didn't like those at all. There was one class at Clemson I had took, this is no joke, I took that class 4 times, called Abstract Algebra. And to this day, I still do not understand what we did in there. The only numbers were the page numbers. Okay, so here we go. The antiderivative area is equal to antiderivative from 0 to 1. I'm going to use a lighter blue so y'all can see it better. X minus x squared dx. So the area is going to be equal to x to the second power over 2 minus x to the third power over 3. Evaluated at 0 and 1. And now you're done. Now this is the setup. So put out here setup, because in some cases in Calc 2, they may just ask for the setup. So A is equal to parentheses squared over 2 minus parentheses cubed over 3 brackets minus brackets, parentheses squared over 2 minus parentheses cubed over 3 brackets. And yes, I know this is 0. But what I tell y'all is when you evaluate, just write it out like this first and then plug in the numbers. Now, I know that 0 is going to give us 0. I know that. But I wanted to make you sure you understood the people that do this right here are the people that don't make careless mistakes on the test. The people that don't do it, you can't tell them anything anyway because they invented calculus. All right, so I'm going to put my 1 in here and my 0 in here. And of course, those go out to 0. And you're left with A is equal to 1/2 minus 1/3, which is equal to 3/6 minus 2/6, which is equal to 1/6 square what? Units. And I can tell you right now, that is a test question, and it might have an x squared here and an x to the 3rd here. It may have an x to the 5th and an x here. Pretty simple. I mean, you got 4 things to do. 1, graph. 2, intersection. 3, setup. 4, plug and chug. Well, actually 4 is finding the derivative, antiderivative. So I guess you could put this as 4. And then plug and chug is 5. I got another good test question right here. Follow this one up. Y is equal to x, and y is equal to x squared. No, that's the same one, sorry. Oh, here it is, that's why I got it mixed up. Y is equal to x squared, and x is equal to y squared. Or, and I'm going to put a blank right here because you can change that if you wanted to. So go ahead, and it is 3:56. Let me give y'all 2 minutes to get this one done. Start my clock. 2 minutes to at least get to the setup.
Gmail.
They must have found a vaccine.
You gonna be the first one to get it?
Huh?
You gonna be the first one to get it?
Hell no, I ain't even worried about it. Like I said, after November, it's going to go away or it's going to get worse.
Sounds like
No, I just noticed 2 or 3 things on the stock market. 3 or 4 pharmaceutical companies just jumped up to 43% and 21%. I bet you $1 somebody's done found a vaccine or something.
Johnson & Johnson just moved to the 7-day trial.
Did they?
Yep.
Well, Regeneron went up 16%. Moderna went up 44%.
Yeah,
I don't think the stock market has anything to do with the availability of a vaccine right now. It will take many, many months before a vaccine is widely produced and proven to be safe.
I'm going to sell off just in case. Yeah, it said, let's see. Yeah, both of them went up. I just thought it was interesting. Excuse me. I guess I got Rona. Oh, shoot. Okay. So we've got a sketch, and that comes out to be y is equal to what? Square root of what? X. So I'm going to do it in the first quadrant because you can't take the square root of a negative, so it has to be in the first quadrant. This, we'll do this in pink. Y is equal to x squared. And we'll do this one in blue. So we know the parabola looks like this. And the hyperbola looks like this. Now, it may look the same and the numbers may come out the same, but the main thing is that you see, and it's not going to come out the same because they're closer together. The process is the same. So 1, I did my sketch. Done that. Intersection 2.
0 and 1.
Okay, x squared equals square root of x, and that's going to be x squared, or I'm going to square both sides to make life easy on myself. X to the fourth is equal to X. And then when you get X is equal to X to the fourth, when you basically finish it, you're going to get X to the fourth minus X is equal to 0. Factor out of X, and that's X minus X to the third minus 1 is equal to 0. X is equal to 0 and X is equal to 1. So 0 and 1. So now we can set up our number 3. So area is equal to the antiderivative from 0 to 1. My upper value is square root of X minus X squared. Now let me ask you a question. Let's say I made a mistake and put X squared first minus square root of X. Will that make a difference? Yes or no?
I would think it would.
Actually, it will not. It will make it negative. But what did I tell you about area?
It can't be negative.
It can't be negative. So you would just take the absolute value. If you were just doing it on a test, you would take the absolute value of that negative, and that would be your area. So don't feel bad if you mix that up. But just remember, there is no negative area. That's like saying from here to Atlanta is negative 235 miles. There is no negatives on signs. There is no negatives on area. Okay, so now if you want to do 4, 4 would be the derivative. Antiderivative. We could change that into X to the 1/2. So that would be X to the 3/2 over 3/2. So X to the 3/2 over 3/2. I'm leaving a step in there. Minus X to the 3 over 3, evaluated at 0 and 1. This turns out to be 2/3 X to the 3/2 minus X to the third over 3, evaluated at 0 and 1. Now, as we said before, most of the time when you plug in 0, it's going to go out. So I'm just going to put an X. I'm going to put a red X on 0, meaning that when we plug 0 in, we're going to get 0 minus 0. So I'm not worried about that. And when you plug in 1, you're going to get 2/3 minus 1/3, which is equal to 1/3 square units. Capiche?
Yes,
Now, one that you'll always see on a test is one like this. I don't think we did it. Y is equal to X, and Y is equal to X cubed. Now, on some of these, you might get -1 to +1. Symmetrical. So let's see what happens. We know, I'm going to go ahead and show both because let's do the colors. Let's make this one pink and make this one blue. And X is a 45-degree angle. And X to the third is a squiggle. And the squiggle looks something like this. Now, in this case, you have two symmetrical areas. I'm going to do those in yellow. And again, I only care about total area because that's what you do in real life. Okay? So all I care about is total area. Net area, this would be negative blank. This would be positive blank. That would be net area. But I only care about total area. So I'm going to set equal 0 is equal to x. And that would be, x. And I'm sorry, I'm just a brain bubble. X is equal to x to the third. And 0 is equal to x cubed minus x. X squared minus 1. There's your positive and negative 1 right there. Equals 0, and 0 is equal to x, and 0 is equal to x squared minus 1. So we've got negative 1, 0, and positive 1. Now, one of the reasons this shows up on a standardized test or a lot of tests is because they want to see if you can do just 0 to 1. Why would you just do 0 to 1 and multiply by 2? It's less work. Okay? So this is 1. This is 2. 3, we're going to set up our antiderivative or definite integral from 0 to 1 of x minus x cubed dx. 4, take the derivative, Hubert. 2 brackets x squared over 2 minus x to the 4th over 4. Evaluated at 0 and 1, and of course 0 goes out. So that's going to give us 1/2 minus 1/4. 2 times 1/2 minus 1/4. 2 times 2/4 minus 1/4. 2 times 1/4 is equal to 1/2 squared units. And that's 5. Plug and chug would be 5. And what I'm doing, basically, we did derivatives. And in chapter 2, I'm showing you why we did derivatives so you can find the first and second derivative, whether it's in physics, whether it's in business, whether it's in biology, whether it's in whatever. Okay, so you can find increase and decrease in values or velocity and acceleration, or whether you can. So that's why I did. And then this is the product of finding the antiderivative. You'd be able to find the area between two curves. So this is kind of like a piece of puzzle fitting together. Question, gripe, complaint?
Oh, you don't want to hear me gripe and complain.
No, I don't. Okay. That's all I'm going to cover today. Why? Because I got a little bit that I'm going to cover Monday. And then the rest is going to be questions on Tuesday and Wednesday. Okay? So Monday I've got another little bit, and that's going to be I'm going to introduce you Monday. I'm going to introduce you. And the reason I can't do it today is because when they fixed my computer, they took off my geospace, which that's where I showed you those three-dimensional, calculus and motion things, so I couldn't show you this today. So I'm going to introduce to you disc and washers. Now notice I put what? Introduce. So I'm just going to show you a little bit of what disc and washers do. And it's going to follow the same lines, what we're doing right now with finding area between two curves. So I'm going to show you probably 3 to 4 problems. So I've shown you 3 to 4 problems, 3 to 4, chapter 2, which is first and second what? Derivative. I've shown you 3 to 4 area between two curves, and that's chapter 5 or chapter what, 6? And Monday, I'm going to intro you to disc and washers, okay, which is how you find volume between two curves with a hole or a space in between. Or I'll show you, but it's so I can't, there's no way I can show you unless I show you in a 3-dimensional types application. And I'm not even going to try to draw it because I can't draw. And I can teacher draw, which means I can draw halfway. But when it comes to 3-dimensionally, So I'm not even going to try to do that today. Now, look for a homework coming up either tonight, tomorrow, probably tomorrow, because that's when I have time. And it's going to encompass this and this. I might put 1 or 2 problems right here so you can just work them. Okay, this is going to be called increasing, decreasing, and inflection. This is going to be area and curves or something like that. Talking about 4 to 5 questions here. Talking about maybe 5 to 6 questions here. And that will be for y'all to work over the weekend, as well as Friday, as well as Monday and Tuesday and Wednesday. Work on all that in chapter 5. Okay. Let me call the roll and turn off everything. Now that I can see y'all, it's a whole lot easier to take the roll. Let me turn off, let me turn off the recorder and turn off